So for the 9-3 day 2 note, the first thing I'm going to start with is just another way to think about the radian to degree conversion. So in the past, when we moved from radians to degrees, we would multiply by 180 over pi, right, in order to get the degree equivalent. As we move forward, this is another way that you can think about that conversion. So you're answering the question, how many degrees is 3 pi over 4? Well, does everyone agree that pi is just 180 degrees? Pi is equivalent to 180 degrees. I can think about this like it's a substitution problem. If pi radians is 180 degrees, then I can just plug in 180 for pi. You're always going to divide 180 by the denominator first, and then multiply by the coefficient in the numerator. So for example, if you've got 3 pi over 4, I'm going to start by plugging in 180 for pi, and just taking 180 and dividing it by 4, which would get you a 45 degree angle, and then multiply by the leading coefficient of 3. So you get 135 degrees. Just make sure the ratio that you start out with simplified, plug in pi, and then simplify that expression. It's another way to think about the conversion. So try it. Convert 2 pi over 3 radians into degrees. Let's do the one to the right first. I'm going to start with pi over 3. What is 180 divided by 3? 60. So I have 2 of those 60 degree angles. What does 2 60 degree angles give you? 120 degrees. See how quick that is? Okay, so rather than debating, should I multiply by 180 over pi? Should I multiply by pi over 180? This is another way to convert to degrees quickly. It doesn't always work. You'll see over here, if I try to use that conversion method with 5 pi over 7, you run into some problems. Right? If you try to do the pi over 7 first, what is 180 divided by 7? 25.7. About 25.7. So you can see that that's not exact. It's about 25.7. So you'd be multiplying 5 by about 25.7. So it's not going to give you an exact amount for the degrees. Does everyone see that? So when I would use this is anytime you see a radian measure that's in the unit circle. That's always going to come out nicely. So if it's one that you recognize from the unit circle, just use this method right here because it'll divide out evenly. You could do 5 times 180 divided by 7 though. If you simplify the numerator first, what's 5 times 180? 5 times 180. You get 900, right? And then what's 900 divided by 7? That's still going to be a rounded answer for degrees. Okay, so you can do that. Any questions? I think you get about, what did I get? 128.57 degrees. Okay, it's not as nice looking, but it still works. It's not as quick as something like 2 pi over 3. Okay. All right, so the first core concept box talks about reference angles. To build a reference angle, we always go from the terminal side to the x-axis. Yeah, so reference angles is formed by the terminal side and the x-axis. You can see some examples down here in quadrants 2, 3, and 4 of what the reference angle looks like. In quadrant 2, this is what the reference angle would look like. In quadrant 3, we have this reference angle. And in quadrant 4, that would be a reference angle. Always goes from the terminal side to the x-axis. And it gives you some mathematical ways to derive the reference angle down here. All right, so in this example number 3, we need to first fill out the blank. The reference angle is the blank blank angle formed by the terminal side and what axis? The x-axis. What am I going to fill in those other 2 blanks with? How would you describe the reference angle? It has to be blank and blank. One starts with a P, one starts with an A. Positive. The reference angle has to be positive. Very good. Very good. And then acute. What does acute mean? Less than 90 degrees. Okay? It's got to be a positive acute angle. So in example 3, it says find the reference angle for 5 pi over 3 and negative 130. Here's someone's going into trig next year. It might be easier for you to convert any radian measure to degree form and then convert it back at the end. Okay, a lot of people work better in degrees. So if my angle is 5 pi over 3, let's convert that to degrees. What's pi over 3? 60 degrees. This is a 60-degree reference angle. So we have 5 of those 60-degree angles. So how many degrees is that? 300 degrees. So that helps me to understand my picture. I'm looking at a 300-degree angle. It's going to be down here. And that's my 300 degrees. Then to find my reference angle, I always go from the terminal side to the x-axis. This right here is my reference angle. What would my reference angle be if I'm stopping 50 degrees short of a full revolution? What do you think? Ryan, what do you think the reference angle is going to be? 60 degrees. Very good. Now, the only comment I have about converting to degrees is that at the end, you're going to have to convert back to radian. Okay? If your question starts in radian, then your answer should be in radian. If your question starts in degrees, then your answer should be in degrees. Okay? So, how many radians is 60 degrees? Say it loud, Penny. Pi over 3. Very good. If you're not sure, just multiply by pi over 180, and it'll get you back to the radian equivalent. Now, for those of you that are pre-calc bound, I want you to think about it a slightly different way. So I need to first draw my 5 pi over 3 angle. If I'm looking at the circle in radians, this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and then a full revolution would be 2 pi. Does everyone agree with that? So I'm looking at 5 pi over 3. I'm going to divide my unit circle up into pi over 3 chunks. Thinking about those pi over 3 chunks. So in this first quadrant, I have one of those pi over 3 chunks. 1/3 pi. Okay, that's one of those pi over 3 chunks. Now, see how this is 1/3 pi? Here I have 1/2 pi. If I add on another pi over 3 chunk, I'd be at 2 pi over 3. I need to know, does that go into the second quadrant or does it stay in the first quadrant? 2 pi over 3, is that going to be bigger than pi over 2 or less than pi over 2? Is 2/3 bigger than 1/2 or less than 1/2? 2/3 is bigger than 1/2, right? So 2 pi over 3 would go into that second quadrant. Okay, so that's going to be the terminal side for 2 pi over 3. What's 3 pi over 3? It's pi, right? Pi, another word for that is 3 pi over 3. So here's my 3 pi over 3. Another chunk would be 4 pi over 3. Probably going to be down here. Let's check and just make sure that 4/3 is less than 3/2. 4/3 is 1.3. And 3/2 is 1.5. Okay, so 1.3 is less than 1.5. Okay? And then I'm guessing that 5 pi over 3 is going to be in the fourth quadrant, but just make sure that 5/3 is bigger than 3/2. 5/3 is 1.7 approximately, and 3/2 is 1.5. Okay, so that would be bigger. Okay. And then what's 6 pi over 3? 2 pi. That's your full revolution. Okay? So I'm looking for the reference angle for 5 pi over 3. Here is my angle 5 pi over 3, and I want to find the reference angle from the terminal side to the x-axis. So how many pi over 3 chunks am I missing from a full revolution? See how that's just one of those pi over 3 chunks? If I add on another pi over 3 chunk to 5 pi over 3, then I would get the full revolution. So my reference angle is pi over 3. That's just another way to think about it. For now, if it's easier for you to convert to degrees and then convert back at the end, that's totally fine. Okay, but the more comfortable you become with memorizing and filling out that unit circle, the better you'll become at doing the second method. So I just know that 5 pi over 3 is in that fourth quadrant just because I have my unit circle memorized. Okay, that's why it's important to memorize your unit circle. All right, the other one is negative 130. This one's already in degrees for us, which is nice. I have to go clockwise though. Right? Start at the initial side and go down. Negative 90, and I'm going to stop short of negative 180. I'm going from my terminal side to my x-axis. Here's my reference angle. How many degrees is my reference angle going to be? Was it? 50. Yes, that's correct. And I even like how you said positive 50. This is negative 130. Think to yourself, how much more would you need to get to half a revolution? 180. You need 50 degrees more. You take 180 degrees and subtract away the 130 degrees. That's another way to get 50. Okay, but it's always a positive acute angle. So don't put negative 50. It's got to be positive. Any questions on finding a reference angle? All right, so there's a couple reference angle questions on your homework. So I just want to try a couple more. Let's do 5 and 7. So number 5 is 210. Let's go ahead and draw 210 degree angle. What would that look like? This is 90, 180, and I'm stopping short of 270. Right here's my terminal side. This is 210 degrees. Everyone agree with that? Okay. So now draw your reference angle. You go from the terminal side to the x-axis. So it's that angle right there is the reference angle. Okay. So what is my reference angle going to be equal to? Any guesses? Gabby, what do you think your reference angle would be? 30 degrees. Excellent. Yeah, you can say that you're taking 210 degrees and subtracting away 180 from it to get 30 degrees. Okay, we all know that from here to here is 180. So I have to think about what extra little chunk you have to add on to get to 210. You have to add on an extra 30 degree chunk to get to 210. All right, let's talk about this one. Let's try the degree conversion method first, and then we'll talk about it using pi over 9 chunks. So if I have pi over 9, that's 180 divided by 9. That gives you 20. Yep. And if I multiply that by negative 7, that would give me negative 140. So that helps me to better understand where my angle is. Negative 140 degrees. We have negative 90. And I'm going to stop short of negative 180. Here's negative 140 degrees. And here's my terminal side. So now to get the reference angle, I go from the terminal side to the x-axis. So this is my reference angle right here. So what would my reference angle be equal to? What do you think? Davis, what do you think your reference angle would be? How many degrees? Like if this is 140, and you know that half a revolution is 180, then it would be 40 degrees. Excellent. And it's got to be that positive 40 degrees because we know reference angles are positive acute angles. Can I leave my answer like this? No, I started in radians, so I have to end in radians. Okay, if you do the conversion, you got to convert back. So I'll have 40 times, to convert back to radians, I'll multiply by pi over 180. So what does that reduce to? What is 40 over 180 reduced to? 4 over 18. What's 4 over 18 reduced to? 2/9. So that would be 2 pi over 9 would be the radian equivalent. questions about that? If you're someone going into pre-calc, it might also be good to think about dividing it up into pi/9 chunks. Okay. We're going in the negative direction, right? -7 pi/9. So this would be 0, -pi/2, -pi, and -3 pi/2. So dividing it up into pi/9 chunks, we have -pi/9, that's 1 pi/9 chunk, -2 pi/9, that's 2 of those pi/9 chunks, -3 pi/9, 9. I don't know, I'm getting kind of close, -4 pi/9, 4/9, what is that compared to 1/2? 4/9 is 0.4. So we're not quite to 1/2 yet, right? 0.5 is 1/2. But what about 5/9? 5/9 goes to 0.6. Okay, so that would be bigger than 1/2. So I'm going to do -5/9, -6/9, -7/9, 7 pi/9. Now I'm thinking to myself, well, this is -9 pi/9, right? That's what would reduce to -pi. So I must have to fit -8 pi/9 in here as well. Okay. So my original angle was what? -7 pi/9. So I'm going this direction, and that's where my terminal side would be. This right here is your terminal side. So now thinking about the reference angle going from the terminal side to the x-axis, how many pi/9 chunks do you need for that reference angle? Well, you can see you have 1, 2. So there you would have a reference angle of 2 pi/9 still. Here's 2 of those pi/9 chunks. Just dividing up fractions. That's why I worked so much with fractions in the last section. Use whatever method's easier for you now. When I first started, I liked the degree conversion method way better. Okay, so if that works for you better now, that's great. I'm not going to tell you which one. All right, the last example that we're going to work with today is evaluating trig ratios using reference angles. So to be successful with that, we just have to understand whether or not sine, cosine, and tangent are positive or negative in each quadrant. So the first thing I want you to do is just draw 4 right triangles. In the first quadrant, here's the terminal side. I'm going to drop an altitude from my terminal side to the x-axis. From the terminal side to the x-axis. Okay. I'm going to draw a right triangle in my second quadrant. I'm going from the terminal side to the x-axis. I'm going to draw a right triangle in my third quadrant, going from the terminal side to the x-axis, and same thing in my fourth quadrant. Okay, I call it my bow tie triangles. Okay. Bow tie triangles have their base on the x-axis. Now, think about your point, this point right here. I would go over a positive amount and then up a positive amount. Does everyone agree with that? To get this point, I would go back a negative amount and then up a positive amount. This is kind of what we did when we filled out the unit circle. Here I went back and then down, and then here I'd go over and down. Okay, so just filling it out with pluses and minuses. Keep in mind the radius is always going to be positive, so my hypotenuse I'm going to label as being positive every time. Okay. Remember, when we filled out the unit circle, your cosine values are your, what kind of values? X values. And your sine values are your Y values, right? And what was tangent when we filled out the unit circle? Y over X. So I'm going to think about what the sine of cosine, sine, and tangent are? Is it positive? Is it negative in each quadrant? I just want to know where are my ratios positive? Okay. In the first quadrant, are your x values positive? Yes, so cosine's positive. Is your y values positive? Yes, so sine's positive. Would y over x be positive? Is your y value over your x value positive? Yes. So in the first quadrant, everything's positive. So I'm going to put a big A for all. Big A for all in the first quadrant. What's positive in the second quadrant? What? What'd you say? Sine is positive in the second quadrant, right? My x values are negative, my y values are positive. Thank you. My x values are negative, my y values are positive. And then if I think about tangent being y over x, a plus over a minus is going to be a minus. So the only thing that's positive here are your y values or your sine values in the second quadrant. So I'm going to put a big S. Sine's positive. In the third quadrant, what's positive? Cosine positive? Are your x values positive? No. What about your sine values, your y values? Those are negative. What about y over x? What about negative over negative? What's a negative divided by a negative? A positive. So in this quadrant, tangent is positive. And in the last quadrant, what's going to be positive? Cosine. Very good. You can see that your x value is positive here. Okay. So I like to use this phrase, all students take calculus, to remember this. All students take calculus. See how it forms a C in the middle for calculus? Okay. That helps you remember what's positive. So here, everything's positive. Your sine's the only one that's positive. Tangent's the only one that's positive. Cosine's the only one that's positive. Now, with that said, you have to remember your reciprocal identities. For example, if sine is 1/2, then what's cosecant? 2 over 1. See how if sine's positive, then the reciprocal is also positive? Let's go. So if sine's positive in this quadrant, what else is positive? Cosecant, that's its reciprocal. If tangent's positive here, then what else is positive? Cotangent. Okay, and if cosine's positive in the last quadrant, what else is positive? Secant. Okay, it's just because those are the reciprocals. Okay, so we're going to use that information in the last example. All students take calculus. Last example, using reference angles to find functions. The series of 4 steps. The first thing you are going to do, always, is draw the angle. Okay. So you draw the angle. Then you're going to find the reference angle, okay, just like what we were doing in that example earlier, finding reference angle. Okay. Then you're going to evaluate the trig function using the reference angle. And then the very last step is to label whether that trig ratio is positive or negative. And what you're going to base that on is all students take calculus. What we just did. It's going to depend on what quadrant it's in. Okay? If the trig function is in a different quadrant, then it might be positive or it might be negative. So you have to think about what quadrant you're working in. Okay, so in the first example, we're looking at tan of negative 240. How does this feel? Yeah. Thanks, bye. Yeah. All right, so I'm going to draw the angle first. Negative 240. So I go clockwise. Right, this is negative 90, 180, and I'm stopping short of negative 270. Okay? So that's negative 240. Then I need to find the reference angle. From the terminal side to the x-axis, what is the reference angle here? Yeah, that'd be 60 degrees, right? From here to here is 180, so an extra little chunk would be 60 degrees. Okay, reference angle is 60 degrees. Okay, you can just take 240 minus 180 to get 60 degrees. Okay? So I find the reference angle. Then I'm going to evaluate the trig function using the reference angle. Remember, if I have a huge angle, negative 240, can I build a right triangle using that angle? No. If you have an obtuse angle, you don't have a right triangle. Remember, you can only evaluate trig ratios with right triangles. So because this is an angle that's bigger than 90 degrees, I have to use my reference angle to help me find the trig ratio. So I'm still going to write tangent. It's just I'm using 60-degree reference angle to get what that trig ratio is. Okay, so what is the tangent of 60 degrees? You can either use the chart that you filled out in the warm-up, or just quickly draw a sketch here of a 60, 30, 90 triangle. Radical 3, 1, and 2. The tangent of 60 degrees would be opposite over adjacent. Right, radical 3 over 1. Okay, so evaluate the trig function using the reference angle. Now my last part is to label plus or minus. I ended up in quadrant 2. What's the only thing positive in quadrant 2? All students take calculus. Sine is positive in quadrant 2. Am I working with sine or cosecant? No. So I have to put a big old minus out front just because I know that tangent is negative in the second quadrant. Okay, so that's the 4-step process you go through. I'm going to do the same thing with this part B. I'm going to convert it to degrees first, though, just to understand what we're working with. Pi over 6 is how many degrees? 30 degrees. Right, what is 17 times 30? I think that's 510. Right, so how much am I going around? I'm going around at least one revolution, and then how much more? What is that? What's 510 minus 360? 150, so I'm going around an extra 150. So this is my terminal side. I'm thinking about this like it's 150. So what's my reference angle from the terminal side to the x-axis? That would be 30 degrees. Once you find your reference angle, I'm still using cosecant. I'm taking the cosecant of 30 degrees. Look at your chart. What is the cosecant of 30 degrees? 2. Is cosecant positive or negative in the second quadrant? All students. Sine's positive. So is cosecant positive? Yes, because it's the reciprocal. So my last step is to label whether it's positive or negative. Okay. I only put a couple of these on your homework. Okay, I think I put like 2 or 3 maybe. We are going to be working a lot more with this next class. This is a big shebang in Chapter 9. Evaluating trig ratios using the reference angles. It's one of the hardest topics in Chapter 9, but it's a topic that you have to know going into your course next year. Okay, so we're going to be doing lots more practice with that. I'll see y'all later. The only homework is the Big Ideas Online assignment for tomorrow, so just make sure you get that finished for me.